Okay, in this video, we're going to look at how to calculate the concentration of solutions in grams per decimeter. Okay, so here we have a question about concentrations. And the question reads 3.14 grams of solid copper sulfate was dissolved in water and made up to 250 centimeter cubed of solution. We've been given the equation here, which is very unusual. And then the command words are calculate the concentration of this copper sulfate solution. So the first thing to do with a question like this is to use a pen to either circle, or as I'm doing here, I'm highlighting in yellow, but often you won't have a highlighter. So just circle with your biro the numbers involved. This is especially important in chemistry questions. So 3.14 G, what does the G stand for? Well, it's grams and that's mass. So I've labeled it mass. And then over here, you'll see we've got 250 centimeter cubed with a tiny little 3. What does that 3 stand for? Well, that is our symbol or our unit for volume. So I want to identify, first of all, these two numbers, one as mass and one as volume. Now you can just label it M and V. I've written mass and volume, and that's the most important thing to do, because now you know, oh, I need to use my equation for mass, volume, and concentration. And I like to put these into triangles. So I put M for mass over the top of C times V. And this makes it really easy to work out the calculation. So here we go. Calculate the concentration. That's the command word. I've underlined that. So I know I need to find C. So what do I do with M and V? And G per dm to the minus 3, that's the units. You can see there, I've underlined there. So we definitely know we're trying to find C. Well, I need to do M divided by V. You can cover up using your thumb the C, and then you know I've got to use M divided by V. And that equals C. So first of all, we've got to locate M. Now, luckily, as we read through right at the start of this question, we focused on labeling the mass M. So we know the mass is 3.14. We also wanted to label the volume V. So I just need to do 3.14 over the volume. And the volume is 250 centimeters cubed. Now, this is actually incorrect, but I'm going to show you anyway, because if you can just get this far, you'll get 1 out of 2 marks. So 3.14 divided by 250 is 0.0125 grams, but instead of per decimeter, it's per centimeter cubed, because we use centimeters. So what's this thing, the dm here? This will only get us 1 mark, and we want both marks. Look down here, I've circled the concentration's actually in dm to the minus 3, not cm. So I need to convert cm to dm. Now in chemistry, we always use dm to the 3. And that stands for decimeters. Decimeters is essentially a litre, it's 1,000 centimeters. So if I want to change my centimeters into decimeters, you divide by 1,000, and you will do this in 99% of the concentration questions. You will divide the centimeters by 1,000. So it's a standard thing you need to spot, and you can pick up a mark normally just for doing that. So we're going to re-put this back in, but this time we're going to go 3.14. And we're going to divide 3.14, instead of by the volume of 250, we're going to divide it by 250 divided by 1,000. And you'll get used to this in this question pack. 250 divided by 1,000 is 0.25. So 3.14 divided by 0.25. And that is the volume in decimeters. Notice how I take my time to write the units in my working out. I put the G for grams and the DM 3 for decimeters, or the cm3 for centimeters. This helps me because at any time I get forgetful, I can look back and see exactly where I am and what I'm doing. And the answer here is 12.56. Okay, for the next question, pause the video once you've read through the question and have a go, and then watch the walkthrough and you'll see how to work it out. All right, let's move on. So what do we get the answers for? We get the answers. I'll just put ticks where you could possibly get the answers. You get 1 answer even if you forgot to convert the decimeters. You'll get 1 mark, sorry. And otherwise, you'll get a mark for your working out and a mark for the final answer. Okay, this next question is very similar to the last one. So pause the video now and have a go at it, and then watch the walkthrough. Okay, here we go. The sodium hydroxide solution is made by dissolving 4.3 G of sodium hydroxide in water and making the solution up to 250 centimeter cubed. So again, straight away, the first thing to do, use your pen to circle these numbers. You scan read the sentence, circle the numbers, 4.3g here, that's mass. If you don't have a highlighter, just circle the numbers, write M for mass, write V for centimeter cubed. This alerts you to the fact, oh, it's one of these MCV equations. So straight away when you spot those numbers, even if you don't understand the rest of the sentence or the question, you know it's to do with the MCV. And the command word, calculate the concentration, tells you we're looking for C. So we want to do M over C times V. Once again, we're trying to find C. And so we want to do M divided by V. So what have we got to do? 4.3 grams. And we're going to divide that by what? We're going to divide the 4.3 grams by the volume. And the volume is 250 centimeter cubed. We need to turn the 250 centimeter cubed into decimeters, so we want to divide by 1,000 for the 250, and that's 0.25. So 4.3 divided by 0.25, what's our answer? You should get 17.2, and that is grams per decimeter to the minus 3. Now you might be wondering why we use GDM minus 3. That's just a fancy way of saying G, diagonal line, DM3, so grams per decimeter. It's just a fancy mathematical way of doing that. Okay, this one is more difficult because it's worth 3 marks, and we'll show you why. Don't forget to pause the video and have a go, and then I'll go through the answers. So once again with this one, we've got the sodium sulfate solution was made by dissolving 28.4 grams of sodium sulfate in water to make 250 centimeter cubed of solution. So we're circling the numbers and looking at the units. 28.4 G, that's M, that's mass, and 250 cm3, that's V, that's volume. So the main thing is, can you spot what the numbers are? And again, the command word is calculate the concentration, but this time we've got to 3 significant figures. We want to use the same equation. You better learn this off by heart. M over C times V. Make something up stupid so that you can remember it. And let's get into it, because this one is a 3 marker, and the bonus 3 marks are really for the 3 significant figures bit. So what we have to do here is we take the mass, which we now know is 28.4 because we identified that, and we divide that by 250 divided by 1,000. Remember, we have to divide the centimeter cubed. The volume you always divide by 1,000. And so we've got 28.4 over 0.250 or 0.25 decimeters. And I'm writing my units in case I forget what I'm doing at some point during the exam or the question. Volume's always in DM3. So we now work out the answer and write it down. Now you'll probably need a calculator for this one. And the answer is 113.6. Also, let's be aware it's to 3 significant figures circled here. That's 3SF. What that means is our answer should only have 3 numbers in it. Just 3 numbers. So we can either go with 113 or 114. What do you reckon? Well, as the 0.6, as the 6 is bigger than 5, circled here, you take it up, you round up to 114. Pause the video. Have a go. Okay, let's get into this one. When copper sulfate solution reacts with sodium hydroxide solution, a precipitate of copper hydroxide and a solution of sodium sulfate are formed. You can see the equation here. The copper sulfate solution has been prepared by dissolving 6.36 G or grams of solid copper sulfate in water and making the volume up to 250 centimeter cubed. Now, actually, with all this writing, we don't actually need any of this stuff. So what you need to get on the lookout for is in exams, just hunt down those numbers and circle those numbers and check the command word to see what you're actually searching for. So again, 6.36 G, what do we know that is? That's mass. 250 cm to the 3, we know that's the volume, V. They've asked us to calculate the concentration, so we need to find C. And once again, like the previous question, they've asked us to do it to 3 significant figures. This one's worth 3 marks. So what are we going to do? Once again, we're going to do M over V equals C. So we're going to do 6.36. We're dividing that by 0.25. Why 0.25? Because I did 250 divided by 1,000. Always turn centimeters into decimeters in chemistry. Just get in the habit of that when you're doing mole calculations. What does that equal? Whack that in the calculator and you're going to get 25.44. Now we are supposed to write this to 3SF, three significant figures. And we've got 4 numbers here. So we need to break that down to just 3 numbers. So we've got 25.44, so we could do 25.4. We'll circle that up. What are our possible options here? So do I write 25.4? Do I write 25.44? Or do I write 25.5? What do I do? Well, it's got to be 3 numbers only. So the options are really 25.5 or 25.4. What is it closest to? Well, you see the last 4 is lower than 5. So we round down and we call this 25.4. So you're just rounding to 3 figures. We're rounding it down to 25.4. And finally, we're going to finish with a super hard one. So you might want to pause the video and have a go at this one. The clue here is you've got to use 2 equations. Okay, I'm not interested in all the writing. So I just want to identify what the numbers are. I've got 15.95 GDM minus 3, that's concentration. I've got 50 centimeter to the 3, that's volume. We've also been asked about moles here and given RAM, relative atomic mass. So that's something slightly unusual. We haven't had this in any of the previous questions. But what I can do straight away, if I'm stuck, I'm panicking in an exam, I say, well, I've got C times V. So I must be able to work out the mass, right? I can work out M. So even if I only get that right, I'm going to pick some of these 3 marks up. So spotting those numbers and highlighting them or circling them is key to doing well in chemistry. So the second equation we're going to need is mass over mR times moles. Now I use a lowercase n for number of moles because we've got so many m's flying about, mass and mR. And when I write mR could be AR, which is relative atomic mass. It could be relative formula mass. It could be RAM, whatever. I use mR in that equation. So what we're going to do here, first off, is say, well, hey, I can do C times V to get M, okay? And the first thing I should notice is that my 50 centimeter cubed, what do we do in chemistry? We convert it to decimeters. So I'm going to do 50 divided by 1,000, and I'm going to get 0.05 decimeters. So I want to do C times V for this one. So I'm going to do 15.95, and I'm going to multiply that by the volume of 0.050 decimeters. Okay, 15.95 times 0.050 decimeters, and that is going to give me 0.7975 grams. So even if I only get this far, I've scored some marks in a really difficult question. Now, what did I work out? I worked out the mass. Now, if you know your other mole equation off by heart, which is mass over mR times moles, I'm going to do mass over the mR equals moles, and moles is the answer that I'm looking for. Remember, the command was calculate the number of moles. So I want to do 0.7975, the mass, over the mR. What's the mR of copper sulfate? Well, copper sulfate has the formula CuSO4, which I've circled in the equation. So we want to do 63.5, which is 1 copper, plus 32, which is 1 sulfur, plus 16 times 4 for the oxygen. And that equals 159.5 for the MR. And if I divide 0.7975 by 159.5, I'm going to get 0.005 moles, or 5 times 10 to the minus 3 moles. And there we go.
You're still here? It's over.